Good morning. In today's lecture, we'll continue on Carnot maps. So last lecture, I already explained about the canonical forms, introduction to Carnot maps. So Carnot maps basically will be used for minimizing the number of gates or minimizing the Boolean algebra. Then now let's go to three variable Carnot maps. There are two approaches for using two variable Carnot maps, depending on which approach. So the textbook using different approach than the notes. So in the notes, I use this approach, but in the textbook, we will use different one. So let's forget about what's written in the notes and let's follow what's written in the textbook. So we will follow this. Basically, three variables or Carnot maps has been built based on gray code. So here is the variable z, here is the variable xy. So we know that the order of variables are x, y, z. So the first two variables in the top will be in the columns. Z will be in rows, the third variable. So we have here 0 and 1. Then for the order of the numbers, like based on the gray code, so we have 0, 0, then 0, 1. Gray code means changing only one digit or one bits at the same time. So after 0, 1, we will not go to 1, 0, it will be 1, 1. Then will be 1, 0. So that's, keep in mind that 0, 1, 2, 3. So again like this, 0, 0. 1, 2, 3. That's how we count. So then we will swap, like go from first column, second column, go to fourth column, then back to third when we need to count. So as a result, in order to write them in terms, so here is the variable z, here is the variable x and y, then start counting the first column like M0, here is M1. Then the second column, M2, here is M3. Then go to fourth column, M4, here is M5, then back to the third. M6, this is M7. That's how we do it. So again, first column, second column, go to third, then back, go to fourth, then back to third. That's how we count or how we insert them in terms. Then when we put the values, here is 0, here is 1. So since there's 1, then here the location of z, 0 the location of z bar. Then here is 0, 0, 0, 1, 1, 1, 1, 0. So here is the location of, here's the location of variable x. Here is the location of variable y. Why we put these arrows? These arrows means where the variable will be without bars. I mean, like when I put these two arrows, or this arrow, this indication, look at, here is 1, here is 1. And this is corresponding to x. So this means this is the area where the variable x will be x. Otherwise, in other areas, it will be x bar. Then the same for y, variable y. So we will see that here is y is 1, y here is 1. Then that's why this is the area of variable y where will be y, not y bar. Otherwise, in this column it will be y bar, and this column will be y bar. Then the same for z. Z, here is the location of z when z will be 1. Then that's it. That's how z will be 1, which will be z. Otherwise, in the first row, z will be 0, or will be z bar. Okay? So to write the variables, here in the first column, since all of zeros will be x bar, y bar, z bar. The second column, y, the only one is non-zero, otherwise the rest are 0, so x bar, z bar. Then the third column, first row, third column, X are 1, Y is 1, Z, so Z bar here. Then here is the bar, Z bar, and there's Y bar, Z bar. So where is the location of corresponding values? Here, because again, this is 0, 0, 0, this is 0, 1, 0, this is 1, 1, 0, this is 1, 0, 0. Then in here, this is corresponding to 0, 0, 1. Therefore, we will be X bar, Y bar. Here is corresponding to 0, 1, 1. That's why we have only X bar. Here it will be 1, 1, 1. Then there is no bars. Here it will be 1, 0, 1. Then there is bar above the Y. Okay? You don't need to memorize like where is the location X or Y bar or Z bar. What you need to memorize, and this is very important, how do we input the numbers? How do we insert the numbers? Which is these numbers. 0, how do we count? Column by column. 0, 1, 2, 3, then go to the fourth, 4, 5, then back to the third column, 6, 7. So you need to know this order. You need to know where's the location of zeros and ones, where's the location of X and Y and Z. So basically, you need to memorize this table. It will not be provided in the test. You need to memorize how to manipulate this table. Okay? Any question? Okay. Let's assume, look at this scenario. Here, again, in the notes, I use different notation like X, Y, Z. We will not use this. We will use Z, X, Y, which is what the textbook says. Again, why I build this? Because when I build the notes, I didn't realize that the textbook using a different approach. That's why we have the notes different than the textbook. So how we build this? So make sure that to draw the table, then this is the location of X, here is the location of Y, the location of Z, then write 0, 0, 0, 1, 1, 1, 1, 0. After that, like right in the top of the table, like in the corner, like this, M0, M1, M2, M3, and then here M4, M5, go back to this M6, M7. Okay? The number of blocks equals 2 power number of variables. So in the 2 power 3, it will be 8. That's why we have 8 blocks, which is 8 minterms, or the number of blocks the same as number of minterms. Okay? Now, let's look at the function X bar, Y bar, Z bar plus X bar, Y bar, Z. According to the Boolean algebra, after doing the simplification, it should be X bar, Y bar. That's using Boolean algebra. But we don't want to use Boolean algebra here. We need to use kernel maps. Let's validate this. Can we achieve this using kernel map? It should be X bar, Y bar. How we do this? Look at the variables. So here it's X bar, Y bar, Z bar, plus X bar, Y bar, Z. So you need to determine what's the corresponding minterms in each one. We know how to determine the minterms. Basically, this is 0, 0, 0. This is 0, 0, 1. This is equivalent to M0. This is equivalent to M1. This is F. Here is F. Therefore, F will be the sum of minterms of 0 and 1. Then, we can go to the kernel maps that we build here and write ones at this. So where are the location of ones? There is one located at M0. There is one located at M1. Then we need to group this. So how can we group this? The first observation, try to group 8 blocks. If we cannot achieve it, try to group 4 blocks. If we cannot, try to group 2 blocks. If we cannot, then take 1 block. Okay? So we have 3 variables. Why we are using 8, 4, 2, 1? Because this is 2 power 0, 2 power 1, 2 power 2, 2 power 3. Okay? That's why we are using, why we cannot achieve try to group 6 blocks, because we need to be this in terms of 2 power something. Then, when we are grouping 8 blocks, which means we will get we have 8 blocks, and we group 8, which means all of the function is 1. So f will be 1, which means always 1. If we are grouping 4, then we should have only 1 variable. When we are grouping 2, we will have 2 variables. When we are grouping only 1 block, then we will have 3 variables. So you need to be aware of all of these. Okay? So try to group all of them. If we cannot group 4, when we group 4, we have 1 variable. When we group 2, we will have 2 variables. When we group 1, we'll have 3 variables. So 3, 2, 1. Or 1, 2, 3. And that's it. So let's look at this example. Can we group 4 or 8? No. Can we group 4? No. We have only 2 ones. Can we group these 2? Yes, we can. We can make a box to group this. So therefore, I expect to see my function includes only 1 or includes only 2 variables, because I'm grouping 2 blocks. According to these rules, grouping 2 blocks will have 2 variables. So how to make these 2 variables, or how can we determine this? Look at this area. Is this area between z equal 1 and z equals 0? Therefore, since between z equal 1 and z equals 0, this is the area that we will not use this variable. This is the missing variable. So whenever you see one side is 0, one side is 1, then this is the missing variable that we will not use. Then z, my function will not include z at all. It will be only including x and y. Again, why we are neglecting z, or this z will be the omitting variable, because at this side will be 0, at this part, and at this part it will be 1. So this is the variable that will be neglected. Let's look at x and y. Here is between x equals 0 and here x equals 0. Therefore, it will be x bar. Here is y equals 0. Here is still y equals 0. So y bar. So f will equal x bar, y bar. This is the minimum function that we can achieve. Let's compare this with our answer using Boolean algebra. X bar, y bar. And here is x bar, y bar. Therefore, we are validating that, the result that we got in Boolean algebra and using kernel maps. So as a result, we have a great benefit using this, because we will no longer use Boolean algebra. We can use this kernel map, so we can avoid using these axioms, these theorems, postulates that will take so long time and take a lot of pressure, a lot of work. However, doing this will be much easier, especially with complicated functions. Okay, any question? Okay, again, the order of this will be different than what we have. So most likely our target here is z, here is x, y. So this is the location of x, here is the location of y, here is the location of z, then here 0, 1, 2, 3, 4, 5, 6, 7. Okay? So again, you need to memorize this table. Most likely, I encourage you to write in the corner the numbers of the midterm, so it can be easier for you when you put and make the simplification. Okay, here is an example. Let's do this using kernel maps. We have if sometimes the function can be given like this way, sometimes as midterms. If it's given like this way as a function, what should you do? Write like 0, 1, 0. Here is 0, 1, 1. Then here 1, 0, 0. here is 1, 0, 1. Then this is equivalent to 2, this is equivalent to 3, equivalent to 4, 5. Then we will realize that our midterms are 2, 3, 4, 5. So the question might be in two options, two ways. You might have a function and you need to convert this to canonical form, then find the midterms, or sometimes the midterms will be given direct way, like 2, 3, 4, 5. So you need to know how to handle with this. And you all know how to find the canonical form for any function, right? The sum of products, the canonical form. We should aware how to do this. So no matter what you have any function, when you have any function, convert this to canonical form, find the midterms. So you need to get this in the box here. Get this. After that, you can draw the Carnot map. Let's draw the Carnot map. It includes 8 boxes, 2 rows. Then here is Z, here is X, Y. So here is 0, 0, 0, 1, 1, 1, 1, 0. Here is 0, 1. This is the location of X. Here is the location, location of Z. Here is the location of Z. Here is the location of X. Here is the location of Y. Then put in the corner the midterms. Here is M0. Let me use this color. M0, here is M1, M2, M3, then skip the third, go to the fourth, M4, M5, here is M6, M7. Okay? Now, we already determined 2, 3, 4, 5. Then we can go to 2, 3, 4, 5 and write the ones on it, because this is the midterms, which gives you the location of ones. If we are dealing with max terms, then max terms will give you the location of zeros. So you need to determine where is the location of ones, where are the location of ones, which is the opposites. Okay? So the location of ones at 2, 3, 4, 5. Okay? Is this clear? Now, can we group 8? No way. Can we group 4? We cannot group 4. Why? Because these are separated. So we cannot group 4. Can we group 2? Yes. We can group these two. We can group these two. Then since we have 2 blocks, we need to have 2 variables. By looking at the first block, or here is number 1, here is number 2. Look at number 1. In number 1, when Z equals 0, Z equal 1. So Z will be the missing variable. Number 2, when Z equals 0, Z equal 1, Z will be the missing variable. So we will have 2 variables which is related to X and Y. So in number 1, it will be at this location when X will be 0, so it will be X bar. And Y will be at 1. So it will be X bar, Y. However, the other block, it will be at X, will be 1, and Y will be 0, which is Y bar. So don't forget to add plus. Then we have X, Y bar. So this is the function. Here is number 2. Number 1 and number 2. Then the function will be X bar, Y, plus X, Y bar. So as a result, if you need to simplify this function, you don't need to use Boolean algebra. You can simplify it using Carnot maps. So the result will be X bar Y plus X, Y bar. And that's it. Okay, any question? Okay. Let's look at another example as shown here. So here we have 3, 4, 6, 7. Let's assume that the function given as f equal to pi max terms of 0, 1, 2, 5, like this. How can we deal with this problem? Max terms are location of zeros. So what you need to do, convert the max terms to min terms. because minterms location of ones. So whenever you have max terms, convert this to minterms so you can determine the location of ones. Okay? And we all know how to convert this. It will be in today's quiz as well. How to convert max terms to minterms. And also how to find the minterms. Okay? So, location, look at, because we have 3 variables, then we have the range between 0 to 7. 0, 1, and 2 are not included. I'm sorry, they are in max terms. So 3, 4 are not included. 5 is already here. 6, 7, then that's how we find it. So the next step, draw the table. So here is z, here is xy, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, here is z, here is x, and here is y, m0, m1, m2, m3, m4, m5, m6, m7. The more you practice, the more you memorize this table, then it will be trivial for you. So look, both the location of ones, it will be at 3, 4, 6, 7. Now, how to group those? To group those, can we group 8? No way, they are not all 8. Can we group 4? Can we group these 4 like this? No, because it must be as a square or as triangle. Don't group it this way. So it must be as a square or rectangle. I'm sorry. Rectangle this way, rectangle this way. But you cannot make shapes like this. You cannot group this. So what should we do? We can group these two. And we can group these two. Okay, then all done. Someone can say, can we do this? Group these two? Yes, that's fine. Okay. What else? You still have this one and you still have this one. What should you do? You can group this, then you can group this. But in this case, you have 3 loops. But you already have these 3 loops, but let's look at this loop and let me make it in different colors so it will be much easier. You can make this loop, and you can make this loop. So you will realize that the group in this color is useless. Why? Because the green and the red groups cover everything. Why do I need to make this one? This one means we have extra term, we have something that's useless. Why do we need to add it? Since it's already been covered in the green and the red loops, then that's fine, that's enough. Okay? So when you make your groups, sometimes your initial guess might be including this one, but when you make the other guesses, you might realize that, review your groups and make sure that there is no unnecessarily or unuseful groups or useless groups. So here is group number 1, then here is number 2. So for number 1, we need to look at where is the missing variable. Look for the terms where will be one of the variables will be 0, one of the variables will be 1. For this variable, we will see the variable y 0. Here the variable y is 1. Therefore, in this loop, the variable y will be missing. Okay? Then you will see, look at the variable x. Variable x here is 1. Variable x here is 1. Variable z is 0. Therefore, in this loop, it will be x and z bar. Okay? Let's look at the yellow loop here. In the yellow loop, we have variable z is 1, and we have the missing variable here which is when we have 1 and 0 for x, while, because here look at x, let me change the color, x here is 0, x here is 1, therefore the x will be the missing variable, so with the common here we have y is 1, therefore this loop will be yz, because y is 1 at both sides, z is 1 at both sides, then since 1s will be y and z. So as a result, f will be xz bar plus yz. Okay? So that's how we do the simplification. So you will see homework number 3 will related to Karnaugh maps. So I encourage you to start this after today's lecture. Okay, I think let's go to this slide. Let's do 1, 2, 3, 5, 7. So let's do the Karnaugh map first. Here is C, here is AB. If it's AB or XYZ, the same. But keep in mind the third variable C will be here, and it includes 8 blocks, 2 rows, 4 columns. So here is variable, well, let me write the numbers. Here is C, 0, 0, 0, 1, 1, 1, 1, 0. So here's the location of x, here is the location of y. So here is M0, M1, M2, M3, M4, M5, M6, and M7. Okay? Then let's locate where are the location of ones. The location of ones will be at 1, 2, 3, 5, and 7. Okay? 1, 2. Let me make sure. This is 3. Here is 4. Here is 5, 6. 1, 2, 3, 5, and 7. Okay. This is the location of ones. How can we make the groups? Can we group 8s? No. Can we group 4? Yes, we can. We can group these 4. What the other remaining elements? We still have this one at M2. Can we make it as a lone variable, as standalone variable? Yes, we can. But this is not the simplest way. We need to make it the simplest way. How to include the one, even though I can overlap or can use some other variables, use other numbers or other min terms, even if it was used in the previous. Which is, it's correct, I mean, that's fine to use the one alone, but if we can group it with others, it will be easy, or it will make the problem simpler. How can we group it with others? Can we group this one with 4 variables, including this one, with 4 variables? No, we cannot. Because we need to have, again, as a rectangular or as a square. So, is there any way to group it as two blocks? Yes or no? Yes, we can group these 2. Even though that this number already been included in the first loop, it still can be included in the second loop. That's fine if the other one is not. Since this one is not. So, we can group this. Okay, so let's look at loop 1. Here's loop 2. Loop 1, it includes 4 blocks. When it includes 4 blocks, there must be one variable associated with it. And that one variable is at c equal 1, which is c bar. Which is c. So this will be included in c, the variable c. How about the second block or the second loop or the second group. The second group includes two blocks, which means we need to have two variables. What are these variables? You will see it's located at 0 and 1, which means this is x bar and here is y. So x bar y. Okay? As a result, f will be x bar y plus c. That's it. I think here it's a, b. I don't want to mix it up. This is a bar b. Okay. Then it will be a bar b plus c. And let me change this because in this system we are using a and b. That's why here is b, here is a. Okay. Why I change it? Because the function as fabc, not as, it's not like xyz. So it will be a bar b plus c. Okay, clear? Any question? Okay. Let's assume this scenario here. I'm going to change the variables. So here will be c, here is ab. So here is c, here is a, here is b. So then this function, of course, it will not be right. So how can we group this? You will see that we can make, let's assume it's already this given. This block is given, but without the blue boxes. So you will see we need to group 4. So we can group 4 by grouping this, the first blue box. We group these 4. Then we have one left here. In order to handle this, can we group it with others? Yes, we can. Then we can group it with this one. Okay? So it will be with this block, with the yellow block, it should include one variable. Then we will realize it's basically at the variable b, so it's b. With this block, which is located at c equals 0, therefore there's c bar, and located at a, so it will be ac bar. So as a result, the function will be b plus ac bar. Okay? Any question? Okay. Let's look at this function, but I'm gonna make some change on it because this will no longer be correct, this will no longer be right. Here I'm gonna assume it as a bar c. Okay. Make the color green. A bar c plus abc plus b c bar. So how can we deal with this? Using kernel maps. The first part, this function is not in canonical form. We cannot find the minterms. So the first point for you is to convert this to canonical form representation. How to convert this to canonical form? Look at AC. What's the missing variable? The missing variable is B, right? So it will be A bar times B plus B bar times C. Then the next term is still ABC. The third term, the missing variable is A. Then it will be A plus A bar times BC bar. So as a simplification, it will be A bar BC plus A bar B bar C plus ABC plus A B C bar plus A bar B C bar. Then the next round is look for, is there any common terms? If there's any common terms, remove this and keep it 1. Is there any repeated terms? I don't think so. Then after that, convert this to min terms. This is equivalent to 0, 1, 1. Here is 1, 1, 0, 1, 1, 1, 1, 1, 0. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, I think I messed up. This is 0, 0, 1, 1, 1, 1, 1, 1, 0, 0, 1, 0. Then this is equivalent to 3, equivalent to 1, equivalent to 7, 5, 2. As a result, this function can be presented to be the sum of minterms of 1, 2, 3, and this term is, I think, not 5, it's 6. One, two, three, 6, 7. 6, 7. Okay? What else? What next? So the first step, convert this to canonical form. Next step, convert this to minterms. Third step, do the Carnot map for simplification. So I can avoid using Boolean algebra or the theorems that we have used in the past. Then, in order to do the simplification, do the Carnot maps. So since it's term ABC, here is C, here is AB, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. So here is the location of C, here is the location of A, here is the location of B, then here is M0, M1, M2, or sometimes you don't need to write M, you can write it in the corner like 0, 1, 2, 3, 4, 5, 6, 7. Then the location of minterms are at 1, 2, 3, 6, 7. So how to do the groups? These 4 can be grouped, and we need to group this one, so we can group it using this. Okay? Then using this this group, it should include one variable, which is the variable b. Here it includes 2 variables, which is located at, one of them should be c, the other one, since here b bar, then should be a bar. Therefore, f will be a bar c plus b. So here, according to the answer, because here I did a change, a modification, here the bar should be here. A bar C plus B, and that's what we get here. That's what we got. Okay, is this clear? Okay. More examples. You can try 2, 3, 5, 7. That's your turn, but keep in mind, here is Z, here is XY. Your turn. Remember, this is 0, 1, 2, 3, 4, 5, 6, 7. Sorry. When you do the simplification, please tell me what's the answer. Yes?
Is it x bar y plus xt?
Correct. Right. Let's do it. So here we have 1 at 2, 3, 5, and 7. So we need to group, we can group these two, and we can group the other two. We cannot group the 4. So for this one, here since the location is the location of Z,
This is the location of x. This is the location of y. Then when using this green loop, it will be x bar y, and this group will be xz. Therefore, it will be x bar y plus xz. How about the second one? Please try it and let me know. Okay, what's your answer?
X bar plus X, Y, Z bar.
X bar plus x, y, z bar. Actually, my answer is x bar plus y, z bar. How? Let's draw this and see why the other term is different than yours. So we have 0, 1, 2, 3, 6. We can group these 4, and this is the location of x bar. Then this one, the left, this is left. We don't prefer to group it alone. If we can group it with others, it will be fine. Then we can group it with these two. That's why we have y, z bar, which is located at y area, and this is for z bar. Then this is y, z bar. So it will be x plus y, z bar. Again, if you can join it with other blocks, even if that blocks or if the other blocks has been used, that's fine. If you can make it, it will be fine. The battery. Okay. Test.
Yes. Good question. Oh, that.
Yeah.
What would be X bar plus Y, Z bar? Because the
I think x bar. Yes. Yeah. I missed the bar. I said x bar, but I forget to write it. Yes, it should be x bar. Yes. Thank you. X bar plus y, z bar. Okay, let's assume we have this example. Let's forget about what's written here. We can group these two, and don't prefer to group this one and this one alone. We can do something like, we call it as, use this one and use this one like this way. Use the one at the edges. It can be fine. We can group them. So, as a result, let me make the correction. Here is z, here is xy, so here is x, here is y. So as a result, this function will be, so since the first circle between x and y, then the second one between z, y bar z. Y bar z. Okay? So that's fine. We can group at the edges. It can be okay. So keep this in mind. How about this scenario? Here is z, x, y. So here is x, here is y. In this scenario, we have ones at the edges. So we can group these two with these two. This will be 4. Okay? It's kind of tricky, but at the edge can be grouped with the others. So you can imagine this, it likes a ball, all of this. So we can achieve as a sphere or cloud. So we can group these edges, and this one alone, we don't prefer to make it alone, then we make it with the others. So as a result, the function f will be, this is located into the y bar zone, then plus this located between z and x bar z. Okay? Any question? Okay, so keep in mind, when you do the groups, you can group the edges. It will be okay. It can be fine. Now, before starting 4 variable Karnaugh maps, just let's recall that when we had 3 variables, there used to be x, y, z, or sometimes a, b, c, it doesn't matter. So the number of blocks or number of minterms equals to the number of blocks, which is 2 power 8 to power 3 equals to 8 blocks. Then we can group the blocks like each 4 blocks can be as 1 variable, 2 blocks, 2 variable, 2 variables. If we have 1 block, we can have 3 variables. Okay? Just like, remember this. Now, we will have 4 variables Karnaugh maps. This is as an extension. So, the function might be written as w, x, y, z, or it can be written as a, b, c, d. So, the number of minterms equals to the number of blocks, which is 2 power the number of variables, which is 4. 2 power 4, 16. So we will have 16 blocks. Therefore, we can have 2 power 0, which is 1 block. That will include 4 variables. Or we can have 2 power 1, which is 2 blocks. Then you can subtract 4 minus 1, which is 3 variables. Then 2 power 2, which is including 4 blocks, which will include 2 variables. Now it will be different than the 3 variables because we have larger number of blocks, larger number of variables. Then 2 power 3, which will include 8 blocks, then which will include only 1 variable. And the last one, 2 power 4, which will include 16 blocks. So we will have 0 variable. In other words, f will equal to 0, will equal to 1, because they're all ones. Okay? So that's what we expect to see in 4 variable Karnaugh maps. We should group, can we group 16, then can we group 8, can we group 4, 2, 1, and so on. Now, how is the order of the minterms? This will be, here is the points. So in the past, or this is using the old version or the old notes, let's use one that's in the textbook. Now, how to put the minterms? You will see that this function is written again in gray code. So we have 0, 0, 0, 0, 0, 1, 1, 1, 1, 0. So here is the location of w, here is the location of x. Very similar to what we did into the 3 variables. But the difference here, instead of having 2 rows, we have 4 rows. So we will do the same way: 0, 0, 0, 1, 1, 1, 1, 0. Here's for y. Then here is for z. Okay? So how we do the counting? So we will start like this. Here is M0. Let me make sure I have the right counting. Yes. M0. Here is M1. Now don't go to the third, go to the fourth. M3, M2. Then here is M3. Okay? So we'll count this, 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 then back to here. Okay? Continue. Go to the second row. M4, M5, skip the third, go to fourth, M6, then here M7. After that, skip the third column, go to the fourth. So it will be here M8, M9, then skip the third row. So we'll go to M10, M11, go back to the third, M12, M13, then skip the third, go to fourth, M14, M15. So every time, skip the third row or skip the third column. Go to the fourth, then back to the third. Make the fourth before the third. That's all. That's all. Okay? In case if you miss with the counting or to make sure everything's all right, you can go to Canvas. You will see files, additional notes. You will see here Karnaugh Maps textbook approach. So here is the overall, in case if you want to make sure everything's all right. This is how we do it for 2 variables. This is how we do it for 3 variables. This is how we do it for 4 variables. Okay? Clear? Again, the simplification, depending on powers of 2. If we have 2 adjacent, then we have 3 variables. When we have 2 squares, 3 variables. 4 squares, 2 variables. 8 squares, 1 variable. 16, logic 1. I already discussed this. Now, let's look at this question. Simplify this using Boolean, like using Karnaugh Maps. Let's assume, like the notation, the same in the textbook. So here is CD, here is AB. And then we will see A. I'm sorry, here is C, here is D, here is A, here is B. Then the next step, okay, let's forget about this. Write the numbers. So like here is, write it in the corner. 0, 1, 2, 3, 4, 5, 6, 7. Every time when I go to the third, skip the third. Here there's a third, skip it. So here's 6, 7, 8, 9. Here's third, skip it. 10, 11, 12, 13, 14, 15. Then put the location of ones. We have 1 at 0, at 1, 2, 4, 5, 7, 8, 9, 10, 12, and 13. Now, can we group 16? No. Is there a way to group 8s here? Can we group 8s? Yes. We can group these 8s. What else remains? There is, this one remains, this one remains, and this one remains. Now, how about taking this one? Can we group this one in 8s? No. Can we group it in 4? This is only 3, we cannot. Can we group it in 2? Yes. So we can group it in 2. How about this one? Can we group it in 1? Or can we group it in 8? No. Can we group it in 4? Yes or no? What do you think? We can group it in 2, like taking this and this one in up. Yes. But there's still, we can group it in 4 actually. How can we group it in 4? We can look at this corner, this corner, this corner, and this corner. The 4 corners. I mean, again, imagine this like as a sphere. So this corner and this corner will meet. This corner and this corner will meet each other. Okay? Then we can group these 4 as shown here. So we have 3 variable or 3 loops. The first loop, since it includes 8, which means it will be based on 1 variable. And that variable, which is located into the C bar, because this is the area of C, this is the area of C bar. This is the area of C bar. The other loop, which is the, let's talk about the 4th, the blue, this blue loop, it will be on including 2 variables. So these 2 variables are located at, here is B, so it will be at the outside of B. And in terms of A, it will be sometimes A bar, so A will be missing. Let's look at B, it will be in B bar zone. Look at C, it will be on sometimes C, sometimes C bar, then C is not. Look at D, it will be in D bar loop. So B, D bar. What else? The last one. So it will include 3 variables. Look at A, it is in A bar zone. Look at B, it's in B zone, because when B is 1. Look at C, sometimes C bar, then C is missing. Look at D, it will be in D zone. So it will be A, B, A bar, B, D. Therefore, the function G of A, B, C, D will be C bar plus B bar, D bar plus A bar, B, D. So we can simplify the function using the kernel maps, no matter how much is complicated. Then it will be much easier than using Boolean algebra. Any questions about this example? Okay. Now let's imagine that this question is written in a different way than the next one. How about if this question says that f equals to pi of 3, 7, 10, 11, 15. And your target is to do kernel maps. This is written in max terms. The best way is to convert max terms to min terms. So min terms most likely will be, since we have 4 variables, then 2 power 4, which will be 16, then the min terms list will be between 0 to 15, the range. So let's look at 0. Is 0 included? Is not. So 0 here. 1 is not. 2 is not. 3 included. 4 not. 5 is not. 6 is not. 7 has already been included. 8 is not. 9 is not. 10 is included. 11 is included. Then 12, 13, 14, 15 is included. Okay? Because remember, these are location of ones. These are location of zeros. Okay? Let's do kernel maps, but I'm going to change the variables because this is different. Here is YZ. Here is WX. So this is W, this is X. Here is Y, here is Z. Then let's write the corresponding numbers. So the corresponding numbers, we have, before writing the corresponding numbers, let's write the min terms location. Here is 0, 1, 2, 3, 4, 5, 6, 7, 8, not 8, here it is 8, 9, 10, 11, 12, 13, 14, 15. Okay? Does this make sense? Now, let's put the location of ones. We have at 0, 1, 2, 4, 5, 6, 8, 9, 10, 12, 10, 12, 13, here's 10, 12, 13, and 14. Okay. Now we need to group this. How can we group it? Let's double check. 0, 1, 2, 0, 1, 2, 4. There is no 5, yes, is here. 6, 8, 9, 10. 10 is not included. It's not, I messed up with 10. Nine, 10, 11. So we have 12, 13, 14. 12, 13, 14. I think we have a quiz, right? So let's finish this next lecture, okay? Before it gets the quiz. Next lecture we will do it.